Okay, in this problem, we're going to find Vx using mesh analysis. We're going to use the problem-solving strategies on AC steady state analysis and loop analysis. We specifically want to use mesh analysis here. So if we look at our problem-solving strategy, we're going to assign a mesh current to each mesh. So if we look in the circuit, let's assign we'll have three meshes, so we're going to have three currents: I1, I2, and I3. So now we have three currents. So we're going to need three equations. So we need three equations. So what we're going to do now is we're going to apply KVL to these three meshes. Now we don't have any current sources in here, so we don't have any constraint equations. So let's go ahead and start and apply KVL to this mesh. So if we start here and go around, we'll have 4I1 is a drop across this element. Then we'll have J4 times I1 minus I3 plus J2 times I1 minus I2 is equal to 24 and 0. So this equation becomes 4 plus J6 I1 minus J2 I2 minus J4 I3 equal 24 to angle 0. So there's our first equation. Now let's go in and apply KVL to the other two meshes. And again, we'll just label, we'll have I1, I2, and I3. Okay, so for the second mesh, we have J2 times I2 minus I1 plus 10 to the angle of 0 plus 4I2 equal to 0. So this becomes minus J2 I1 times 4 plus J2 I2 is equal to minus 10. Yeah, so there's our second equation. Now we need to apply KVL to the third mesh. So we'll have 3 minus J2 I3 minus 10 to the angle of 0 plus J4 times I3 minus I1 equal to 0. And this simplifies to minus J4 I1 plus 3 plus J2 I3 is equal to 10. So there's our third equation. Now we have the equations, and if we solve them using MATLAB, we only need I3, and if we look back at our circuit, we'll see why. If we're trying to find Vx, the mesh current I3 flows through these two elements. So I3 then is 4.7207 plus J 1.009 amps. And again, looking back at our circuit, we can see that Vx is 3 minus J2 times I3. So 3 minus J2 times I3, that's 17.4 and angle minus 21.63 degrees.